Okay, this is from my Algebra 2 class. Now, I forgot to email myself the worksheet, and I'm doing this at home, so I'm just going to write the problems down. So I'm going to start off with this one, which I'm really not sure what number it is, but it's one of the first, 10. Let's say it's number 9, even though I have no clue whether or not that's true. So what we want to do is we want to look at this, and the reason I chose this one is because it is in fourth roots, okay? So that means that the answer to those, or the only thing that we're going to be able to pull out, are things that we have 4s in. Okay, so let me show you how this works. 2 to the 4th would be 16, 3 to the 4th would be 81, and 4 to the 4th would be, I'm going to go 16 times 16, that gives me 190, 256. So what we're looking for is whether or not any of those numbers have 16, 81, or 256 as a factor. Now clearly 4 doesn't, 6 doesn't, but 324 might. Now 324 isn't going to have 256 as a factor because we know that if we have 256 and double it, we get 512. So what we're going to do is we're going to go 81. So first we look to see if 16 goes into 324. It doesn't. What about 81? Well, 81 goes in 4 times. Yay! Okay? So now when we go back over here, what we can do is we can write that as, instead of the fourth root of 324, we're going to rewrite that as the fourth root of 81 times 4. Rewrite that as the fourth root of 81 times the fourth root of 4. And we just showed that the fourth root of 81 is 3. So that's going to be, too much all at once. So that's going to be 3 times the fourth root of 4. Now we bring everything else down, because there's no changing it. So we have negative 2 fourth roots of 4, minus 3 fourth roots of 6. So look at that. We have 2 fourths roots of 4. Now remember, we can combine those two because they have the same radicand, that's the thing inside the radical symbol, in this case 4, and the same index, also 4. So we have negative 2 fourth roots of 4, minus 3 fourth roots of 4, minus 3 fourth roots of 6, and we get our answer as negative 5 fourth roots of 4 minus 3 fourth roots of 6. Isn't that nifty? Okay, moving on. See, we already got one done. Easy peasy. So here we have negative third root of 40 minus 2 third root or cubic root of 5 plus 3 third root of 5. Now see, right off the top of the bat, we have 2 cubed roots of 5. So we can just add those up. So now we have negative 30. I don't know why I just said negative 30. We have negative 3. It's not a 3. We have negative 1 cubed root of 40 plus a cubed root of 5. Now, how we got the cubed root of 5 is we went plus 3 minus 2. That gives me 1. So now we want to look to see whether or not we can break that 40 down at all. Hey, Cleo. And we get negative 3, and lo and behold, we have 8 and 5. So again, when we have those cubed roots, we want to look at numbers like 8, 27, 64, 125. Because that's 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. In this case, we have an 8. So we can go negative third root of 8 times the third root of 5 plus the third root of 5. That gives me negative 2 cubed roots of 5 plus the cubed root of 5. So I have negative 1 cubed root of 5, and that's my answer. Number 12. So we have 2 radical 5 minus 3 radical 20 minus 3 radical 20. So we can put those two 20s together and we get negative 6 radical 20. Now we know we should be able to, again, we're looking for square roots here. We're looking for roots that we can pull out. So we're looking for perfect squares. 4, 9, 16, 25. When we see 20, this is a number we're going to see a lot, the square root of 20. We should know that that's 4 times 5, or the square root of 4 times the square root of 5, or in this case, 2 times the square root of 5. So now, instead of 6 radical 20, we have negative 12 radical 5, which is good because we have a 2 radical 5 over there. Bring that down, so now we have 2 radical 5 minus 12 radical 5, and we get negative 10 radical 5. Hopefully that made sense. Next one we're going to do is, again, I don't remember what the number is. We have 3 radical 54 minus 2, 7th root of 6, plus 3 7th root of 640. Now, here, 54. So let's ignore those 7th roots because they're a little scary, and that's okay. So what we're going to do is we're going to look at that square root of 54. And that's 9 times 6. Now I immediately look at that and go, and why I pulled that 9 out was, again, like we just talked about, 9's a perfect square. So I know that I can turn that square root of 9 trapped inside that 54 into a 3 on the outside. Okay, so now we have 9 radical 6. Now, 1 to the 7th, I do not know my 7th powers off the top of my head. I know my squares, and I know some of my cubes. I do not know my 7th powers. So let's do this. 1 to the 7th equals 1. That one I did know. 2 to the 7th equals 128. And 3 to the 7th, 9 times 9 is 81. That's 3 to the 4th times 9 is 700 and something. Okay, so 3 to the 7th is going to be way, 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 way out of what we're looking for. Because what we're looking for is a factor of 640 that is the 7th root. That is a perfect 7th root. So here we have 1 or 128. So let's try and divide 640 by 128. And hey, we get 5. So what I can do, and this is kind of cool, I can go 3 times the 7th root of 128 times 5. Or 3 times the 7th root of 128 times the 7th root of 5. Well, as we just figured out, what is the 7th root of 128? It's 2. So now we have 6 times the 7th root of 5. So now what we're left with is 9 radical 6 minus 2 7th roots of 6. Now, even though we have roots and 6's there, they don't have the same index. See, we have one that has the 7 as an index, and the other one doesn't have a listed index, which means it's 2. So we have 9 radical 6 minus 2 radical 7th root of 6 plus 6 7th roots of 5. And that's our answer. See? We're like halfway there. 16. The square root of 28p squared. So what I'm going to do is I want to break this down. I'm going to look at 28 and go, okay, what are the factors of 28? And again, I'm looking for those perfect squares. I'm looking for 4s, I'm looking for 9s, I'm looking for 16s. Hey, 4. I know that 28 is 4 times 7 times p squared. So now I'm going to break out each one individually and see what I can do with it. So now I have 2 times the square root of 7 times, now remember, squares and radicals and exponents are inverse operations. So if I have the square root of p squared, that just gives me p. Not like urine, that's gross. But anyway, so I end up with 2p radical 7. And that's my answer. Number 18, we're going to go 80b to the 4th. Now, again, I'm looking for 4s, 9s, 16s, 25s, and 36s. So 16 actually works, but I'm going to break this down a little bit easier because I don't expect, and this isn't like in a bad way, I don't expect you guys to be able to look at 80 and go, oh, that's 16 times 5. I do expect you to be able to look at 80 and go, hey, that's 4 times 20. So I'm going to pull a 4 out. And then I'm going to look at that 20, I'm going to go, hey, that's 4 times 5. Pull another 4 out. So now what we're going to do is we're going to go square root of 4 times the square root of 4 times the square root of 5 times the square root of b to the 4th. Square root of 4, 2, times the square root of 4, 2, times the square root of 5, 2. I'm just kidding, it's just the square root of 5. Now for b to the 4th, we end up with b squared. And the reason for that is the square root of b to the 4th is the same thing as 4b to the 4th. We're not doing the 4. Is b to the 4th to the 1/2 power. Now remember, if we have powers to powers, we multiply. Half of 4 is 2. The other thing we can do is we know that we're looking for groups of 2 here. So we want, how many groups of b squared do we have? We have 2. We square root that. Square roots and squares cancel out. And again, we have b squared. Oh, there's 23. Cool, huh? Okay, let's go back. I don't know why it's being stupid. Okay, 23. We have the cubed root of 40p to the 8th. So again, cubed roots, I'm thinking 2 cubed, 8, 3 cubed, 27, 4 cubed, 64, 5 cubed, 125. So those are the numbers I'm looking for as factors. I'm looking for, so I have 40 there, and I'm going, does 40 have a factor of 8? Well, yeah, sure it does. It's 8 times 5, p to the 8th. So now we have cubed root of 8 times the cubed root of 5 times the cubed root of p to the 8th. Cubed root of 8 is 2. Cubed root of 5 is simply the cubed root of 5. There's nothing doing there. Cubed root of 8 gets a little tricky. So we're looking for groups of 3, right? Because we have a cubed root. If it was a 4th root, we'd be looking for groups of 4. If it was a 5th root, we'd be looking for groups of 5. So what I want to do is start pulling out groups of 3. And we have 2 of them. We have 2 groups of 3 p's and then 1 leftover group of only 2. So watch this and see why I sat there and did it in groups of 3. So I have 2 times the 3rd root of 5 times p, because look, if I sit there and go, what's the cubed root of p cubed? Well, those cancel out. So I just get p. So it's p times the cubed root of p squared. So I get 2, put my p's together, p squared times the cubed root of 5p squared. Okay? 26. Cubed root of negative 5 times the cubed root of 16. Now the cubed root of negative 5, so the cubed root of negative 5 times the cubed root of 16 is just going to give me the cubed root of 80. So I'm going to show you guys 2 ways to do this. So the first way we go, that's the cubed root of 8 times 10. The cubed root of 8 times the cubed root of 10. Now the cubed root of 8. Now normally we sit there and go, oh, we can't have roots of negative numbers. Yes, we can. Remember that if it is an odd root, we can have a negative answer, right? Because if we go 2 times 2 times 2, we're going to get 8. If we go negative 2 times negative 2 times negative 2, that's 3 negatives in a row, so we get a negative 2. Now the other thing I could do is I could write it like this. I could go cubed root of negative 1 times 5. That gives me the cubed root of negative 1 times the cubed root of 5, or negative cubed roots of 5. And then with that 16, I could go that cubed root of 16 would be the cubed root of 8 times 2. Cubed root of 8 is 2. So I'd have that times 2 times the cubed root of 2. Now notice here, I have that same index, so I can just multiply the radicands together. So I'd get negative 2 cubed root of 10. I personally like this way better. It just makes more sense to me. But if you like that second way, go for it. As you can see, you get the same answer as long as you're getting the right answer and you're following a legitimate process. You don't have to follow the process I follow as long as the process you follow is mathematically worthwhile. So number 28. We have the cubed root of negative 50 times the cubed root of 10. This gives me the cubed root of negative 500. So again, cubes, I'm looking for 8. That's not going to help here. 27's probably not. What about 125? Well, sure, because 500 is divided by 125 is 4. So we have negative cubed roots of 125 times 4. Negative cubed root of 125 times the cubed root of 4. The negative cubed root of 125 is negative 5 times the cubed root of 4. Okay? So I've actually got a couple more, but I'm going to call it a night. It is pushing 10 o'clock right now, so I'm going to upload this. So if any of you guys are doing homework, I plan on giving you guys at least Thursday and Friday to work on this in class, unless you guys are just like gangbusters and knock it out. But I'm not anticipating a huge amount of that. That's not a knock on you guys. It's just this is something new and confusing to a lot of people, so it's going to take you some time. So I will add more once you guys are kind of done with those first 2 pages. So have a good night, everybody, and thank you.